So section 3.1, we're going to work on calculating the derivative and the slope of the tangent line. The derivative is actually going to be a function that we're going to calculate from our function. But it all relates back to the slope of a tangent line and slopes of lines in particular. So we'll start there with working with slopes. Now, a lot of the work that was done on this was done by a mathematician by the name of Pierre Fermat. And if you've ever heard of Fermat's last theorem, this is the same Fermat. When I quoted Newton as saying of himself, if I've seen farther than those before me, it's because I've stood on the shoulders of giants. One of those giants in my mind was Pierre de Fermat. He was an amateur mathematician. He was a lawyer by trade. He just kind of dabbled in math. So came up with some pretty good stuff. But to kind of get going, let's look at problem number 2 here. It asks us to estimate the slope of a line that's tangent to the curve at this point, and another one that's tangent to the curve at this point. So, okay. Now what I've done to try and make this a little bit easier is I've put other points on this line, and we're just going to count the spaces between these to try and estimate the slope. And this is what you would have to do if you're trying to estimate the slope yourself. So I picked these 2 points, this one and this one, in pink here. And remember, slope is rise over the run. So let's calculate how much of a run there is in moving up from this point to this point. How high do we have to travel? 1, 2, 3, 4. So the numerator of our quotient for our slope would be a 4. How about the denominator? How far of a run is there from one point to the next? 6. So overall, the slope here is 4 over 6, or about 2/3 as an estimate. So, okay. Now, I know this is a negative slope, but is this going to be steeper or not quite as steep as the first line? What would you guess? Yeah, not quite as steep. That'd be my guess as well. So in this case, I picked 2 points, this one here, and then the point of tangency. I'm going to go down 2 and to the right 5. Now I'm going down 2, that's a negative 2 for the rise and a 5 for the run, so a slope of negative 2/5 is about the slope there. So we had 2 lines, call them M1, with a slope of 4/6, or better yet 2/3, and M2 with a slope of negative 2/5. And that's what they're looking for in problem number 2, is for you to estimate the slopes of those lines. Now we did that by using a couple points to come up with the slope of a line. The slope of a line has a formal definition of this slope of a line between 2 points, y2 minus y1 over x2 minus x1. The m is used because I think it stands for monter, which is French for to climb. In any case, let's look at the next problem, problem number 4, is asking you to decide which of these quantities is bigger. And that is, there we go. This one, right down here. This one or this one. Now let's try and understand what these are. The first one is really filling in the slope. y2 minus y1 over x2 minus x1. So the the y2 is just the slope of the line, or excuse me, is the y value at x equal 4. So it's f of 4 is a way to denote that. F of 4 minus f of 1. That's going to be your numerator. Divided by the distance between those 2 points, 4 minus 1. That gives you the average slope of a line, which is right here. I'll call this line 1. L1. So that's in green here for us. Let's compare that to the next quantity. F of 3 minus f of f of 4 minus f of 3 over 4 minus 3. Now they're trying to find the slope of this next line, really between these 2 points, between x equal 3 and x equal 4. What's the slope of the line there? Call that L2. Which slope is bigger, L1 or L2? L1 looks steeper to me, so L1 would be greater than L2, or the slope of L1 would be greater than the slope of L2. Now eventually what our goal is and what we're going to be doing numerically with our work in this section is trying to calculate the slope of the tangent line. Let me remind you how we do that. So let's go back to this demonstration from the other day. So we're going to start out with a couple points. And between these 2 points, we can calculate the average rate of change. That is the slope of the secant line. But the slope of the secant line is not what I want. I want the slope of the tangent line. I want the slope of this line. So what I can do is start out with a secant line, but let this point get closer and closer to this one. So this is one estimate of the slope of the tangent line, but a better one is when I move that point to the right, or if I move that point further to the right. And in the end, what am I doing? What kind of a process am I going through in shifting that point from here where it started to over here? I'm taking a limit. And as this distance between these 2 points decreases, my estimate is getting better and better and better until eventually these 2 points coincide. Instead of having the slope of a secant line, I've got the slope of a tangent line. So that's a nice graphical vision of what we have going here. Let's go back to this then. Now we're going to go back and look at the slope of line L1 again, which is this, and compare it to this. Now I've rewritten it just for convenience. Let me be very clear about it. F prime at 4. This is our notation for the slope of the tan line at x equal 4. So that's the slope of the tangent line at x equal 4. So let's call that line 3. Which quantity do you suppose is bigger? The slope of the secant line between 1 and 4, or the slope of the tangent line at 4? L1 or L3? L1. And again, that's what they're getting after, is what symbol to put in there. And it's a greater than symbol. The blue one. So the blue one's almost flat. Okay, so it's slowed down considerably near that point. Or flatter, I should say. Not almost flat. That's our goal here, is to be able to calculate the slope of the tangent line. And so let me outline a few steps as to how we're going to do that for functions in general. We'll do an easy one to warm up with, and then we'll do a few that are a little bit harder. So to start with, let me give you some instructions as to how to calculate the slope of a tangent line at a point. So calculating let's zoom out a little bit. Calculating m sub tan, so the slope of the tangent line, and there we go, focus, at x equal a, so x equals some function value, or some value for y equals f of x. So you've got some function, you want to find the slope of a tangent line at a particular point. How do you do that? Well, I'm going to break it down into a bunch of steps. You don't necessarily have to follow exactly the way I do it. I should see some work when you do show me your steps, but it doesn't have to be exactly what we have. So the first step is to find f of a and f of a plus h. The second step is to calculate delta y, which is f of a plus h minus f of a. The third step is to simplify delta y divided by h. And the fourth step is to take the limit of this quantity as h approaches 0. So the limit as h approaches 0 of delta y over h. Now, if you were to put all that together into one big expression, I'll show you what you get. But basically, we're going to get f prime at a, which is also the slope of the tangent line at a. That's what we're after. Really, this is no more than this process. y2 minus y1 over x2 minus x1. If you fill that in for these two pairs of points and then took the limit as h approaches 0, you would get this limit. The limit as h approaches 0 of f of a plus h minus f of a over h. That's effectively what you're calculating, and that's going to be f prime of a. All right, but we're going to go through these steps as we calculate it. And like I said, feel free to change them up a little bit if you find it convenient. We'll start with problem number 6. F of x is 3/2 x plus 1. And they give you the point -2 and -2. So they're being kind of kind to you here. Let's understand what you're being given. That's your a, and this is f of a. So we've already got part of our first step handled. Yes, sir? A little more? Okay. So what do we need to do first? Well, we've already got f of a. So what we're going to need next is f of a plus h. So that's our first step. F of a plus h, which is really going to be f of -2 plus h. That -2 is coming from the x-coordinate here. So f of -2 plus h. If I plug that into my function, I'll get 3/2 times -2 plus h, or -2 2 plus h, and then the plus 1 is still here. How does this simplify? What should I do? Down? Yeah. If you distribute this to both of these terms, I end up with -3 plus 3/2 h plus 1. Does this simplify any further? Yeah. So let's just call it -2, right? Plus 3/2 h. So there's your first step. We have f of a and we have f of a plus h. By the way, just a heads up, A lot of times I'm just going to give you this part. You should be able to figure out that part. All right, I know it's awful demanding to put in a value into a linear function, but just be warned. Part 2, I need to calculate the difference between a couple of these functions or a couple of these values. I want to calculate f of a plus h minus f of a. So let's see that calculation. That's going to be our delta y, negative 2 plus 3 halves h minus negative 2. Be careful about the double negative. First one to simplify that gets to do an extra 10 problems in homework. Go, go, go. All right. Good man. Thank you. See me about those extra 10 problems after class. All right. Thanks, Scott. All right. The 2's cancel each other out, and that's a good thing. That leaves us with a very simple expression of 3 halves h. Then what? Well, then we want to simplify this expression, delta y over h. Basically take this answer and divide by h. 3 halves h over h. Victor, does that simplify at all?
You can take out the h.
All right, good. Let's take out the h's. Thank you. So we get 3 halves. Our last step is to calculate the limit. So step 4 is the limit as h approaches 0 of delta y over h, or better yet, the limit as h approaches 0 of 3 halves. Can anyone tell me what that limit is? 3 halves. Okay. So that's the slope of the tangent line. Now, with any just regular line, the slope of the tangent line is just going to be the slope of the line itself. So this isn't a really surprising result in hindsight. But the purpose of this example is to work through the mechanics, just so that you understand the process of finding these limits and calculating really the derivative or the slope of the tangent line. So that's m tan. Slope of the tangent line at x equal negative 2. How are we looking on that one? Looking okay? Let's try another one. Before I go on, are you sure there's no details that I went over a little too fast here? Following this that I laid out right here. Basically, you're calculating this. I broke up the calculation of this into 4 different steps. You can do it a little different, and that's fine. But either way, that's going to give you the slope of the tangent line at some point. We'll call it A. Justin? F prime of A equals the m tan. So this notation is the derivative. So the derivative of f at A is the slope of the tangent line there. All right. Oh yeah, 6 is just a problem number. Yeah. So there's, yeah, nice observation. Yeah, there's no instructions for 5. You're not missing anything there. It ends here. Yeah, it's just kind of a strange coincidence there. All right, let's try one that's a little bit more challenging. Problem number 8. For 8, f of x is 5 minus x squared. And let me give it to you the way that I would give it to you on an exam. And that is, I'm going to ask you to find the equation of the tangent line, or at least the slope of the tangent line, at x equals 3. Now that leaves it up to you to figure out the y coordinate there. But again, I'm hoping that's not going to be a big deal. So the first part, this is really your a equals 3. I need to find f of a, which is really just f of 3. Phil, what's f of 3 going to equal, please? Yeah. A little more. -4. So 5 minus 9 would be -4. All right. So that's f of a. I'm also going to need f of a plus h, or better yet, f of 3 plus h. Now this is going to be a little bit of grunt work. I'm going to take this a plus h and plug it in for x. So that's going to be 3 plus h squared. And you should simplify that. And one of the things you're going to need to do first in simplifying this is to square this out. Now you can, if you want to, off to the side, write 3 plus h times 3 plus h, and then FOIL it all out. I strongly suggest that at this level of math, it's really in your best interest to be able to square these things out in your head. So how do you do that? Well, when you square these things out, everyone gets this part right. They're going to get, 3 squared is 9. And then there's this one squared. That's h squared. But the thing that sometimes people leave off is the middle term. What I do is I steal this 2 here. 2 times 3 times h. Well, that's 6h. So 3 plus h squared is 9 plus 6h plus h squared. You can FOIL it out and get the exact same thing here. 9 plus 3h plus 3h again plus h squared. Combine like terms, and you get the same thing. The important step next is to distribute that negative. 5 minus 9 minus 6h minus h squared. And now there's like terms that we can cancel. John, what are the like terms that we can cancel? Thank you. So, wow. A lot of work to come up with this, and a little bit of work to come up with this. We're finally done with the first step. This part, I just combined the like terms. 5 minus 9 is -4. No. Good question. What we're going to do in the next step is subtract these two. I need to find f of a plus h minus f of a. So f of a plus h, that's this one. F of a. Let's fill in some values there and see what we get. So -4 minus 6h minus h squared minus -4. What kind of simplification am I going to get here? Yeah, the 4 is going to cancel each other out, right? Negative of -4 becomes a positive 4. Those are going to cancel each other out. So all that we're left with is minus 6h minus h squared. Minus f of h. So in this case, it's f of 3 plus h minus f of 3. There's f of 3 plus h, and there's f of 3. So that's where you got the extra -4. All right. That's your delta y. So that's delta y. And in the next step, I want to calculate delta y over h. Please, please, please don't cancel the h into the 6 like that. You can't. You cannot cancel this into this or this into this. Now, somebody asked me just a minute ago, do I need to factor? Here's where I would factor. I'd factor out the h. you're left with minus 6 minus h over h. And that's helpful because now we can get rid of the h. The h cancels. Minus 6 minus h. Almost done. The last step is to take the limit as h approaches 0 of delta y over h, which is the limit as h approaches 0 of negative 6 minus h. Can someone tell me what that limit is? Negative 6. How'd you get it? Yeah, plug in 0, right? The first thing you always try and evaluate a limit is to plug in the limit, and it worked. Great. That's the slope of the tangent line at x equals 3. So some of you know some shortcuts here, and that's great. On the exam, there's going to be a problem like this where I'm going to ask you to do it from the definition. So one problem, no more, just one problem where I'm going to ask you to do it this way. All right? But I do want you to know and understand it. I'm not going to make them really, really crazy. I'm not going to make them find the slope of the tangent line using the definition of the sine function or something like that. Those get pretty way out there. Eventually what we're going to do is we're going to learn some rules for calculating these things. And it's going to make calculating these things a lot easier. But you have to understand where the definition comes from and what can go wrong when you're calculating a derivative. And that's based on understanding these formulas. So we are going to go over them pretty carefully. Yes, sir?
Would it be safe to say that on the exam, the equation that we're going to get to figure out is going to be similar to this one that we just
Yes. Yeah. It's going to be.
It's not going to be much harder. It's going to be.
Yeah, it's going to be simple. I'm not going to give you anything totally off the wall. It's going to be straight from the homework that I assign. Yes, ma'am.
In the very beginning, I believe you gave us the x coordinate, and you said that you expect us to be able to find the y.
Yeah. So I gave you the x coordinate, and you guys found the y coordinate, negative 4. So, yeah, I think that's reasonable to expect. Now let's do a little bit more work with this. One of the things that I certainly want you to be able to do is come up with the equation of the tangent line. The equation of the tangent line actually will give us a way to double check our work as well here. So what couple things do you need to find the equation of a line? Yeah, slope and a y-intercept, that'll be 1. A slope and a point. So if you can use a slope and a point, then y minus y1 equals m times x minus x1. There's your slope, your point slope form of the equation of a line. You need to know m, and you need to know x1, y1. So let's remind ourselves of some algebra here. Our slope in this case, well, that was the negative 6. And the point, well, when I plugged in a 3 for x, I got a negative 4 for y. So let's see what happens when we put these two together and find the equation of the tangent line. Y minus negative 4 equals negative 6 times x minus 3. Let's clean that up. That's y plus 4 equals negative 6x plus 18. I like my lines in slope-intercept form, so I'm going to go a little bit farther. Come up with the equation of the tangent line. So negative 6x plus 14 is the equation of the tangent line. Now what that means is at this point, that line should just kiss the function and then kind of skip off, ricochet off, like skipping a rock on Lake Superior. Let's see that happens. Let's check it out You can check it out on your graphing calculator. I'm going to happen to do it on Desmos, but both of them should work. So here's our function. Here's our equation of our tangent line. In fact, let's add one more thing to it, and let's add that point there. So that's looking pretty good. There we go. So the tangent line just touches it right there and then kind of skips on past. So that's pretty good confirmation that we did everything right. I don't think things are going to line quite so nice and neatly if we made a mistake there someplace. Let me go back and double check you on that. Are we okay with our calculations? Because we're gonna do this again, except it's going to get a little bit harder in one small sense. So before I make it a little bit more challenging, is there anything else you'd like to look at here? Try the delta. Delta is a Greek letter. It's the capital Greek letter. But delta means change in. Basically, it's the change in y. So you can think of this as being, effectively your y2 minus y1. That's what you're getting in is the numerator of your slope calculation. So that's why we use delta. Later on, we'll also use delta x. We'll see delta x. That's just a change in x. All right. This way or the other way? Oh, other way. Well, yeah, the answer here is the slope of the tangent, or is the equation of the tangent line. So that's the final answer. Now, there is another way to ask problems like this, and that is just to have you find the slope of the tangent line. So I hope you see the extra work here in going from the slope of the tangent line to the equation of the tangent line. It just depends on what I asked for in the problem. Yes, sir. I guess I would write it as at x equal 3, because that's the x value where we found it. Okay. Or you could write it at, negative 3, or excuse me, 3 comma negative 4. So it's the point the tangent at that point. So you got an x and y coordinate there. All right.
Now, we would have to specify where that's from on the exam, correct? Like where we would have to write that at x equals 3 or the point.
Oh well, yeah. If you want to be careful, this is the equation of the tangent line at x equals 3. So that'd be nice. That'd be very conscientious if you wrote it all out like that. I mean, believe it or not, occasionally I wouldn't go working too hard for it. Occasionally, people who are really conscientious, I'll throw it on an extra credit point. For people who are very, very thorough and precise.
Like if we don't
If you don't, that's fine. The answer I'm looking for is what I have circled. If I asked you for the equation of the tangent line, if all I asked you for the slope of the tangent line, you can quit here. So try and be careful and read the problem thoroughly, because if you quit here and I ask you to go here, you've missed a lot of work. So you're going to miss a fair chunk of points. If you only have to go here and you come here, then you've done a lot of extra work that you didn't need to do. So I'd suggest you read the problem carefully.
put at x equals x equals 3.
That's a bonus for me.
Okay.
Yeah. Now, one drawback about all this work is if I said, well, gee, I made a mistake. I didn't want it at x equals 3. I wanted the slope of the tangent line at x equals 7. You'd be like, oh, are you kidding me, man? I do all this work all over again. And you would. None of this work that we did in finding the slope of the tangent line or the equation of the tangent line does us any good if I have to go back and do it at another point. So that's a real drag. So what we'd like to do is we'd like to do this calculation just once and then be able to find the slope of the tangent line anywhere we need it based on our derived function. So we're going to calculate the derivative of this function next. And the derivative is going to tell us the slope of the tangent line anywhere we want. So it's just a one and done process. So calculating the derivative of f of x. So it's the derived function. We're going to start out with this function and derive another one. Just like a few years ago in the mortgage crisis, there was lots of problems with derivatives. Those were financial derivatives, but it's the same idea. They derive their value from underlying securities. So, similar steps. We already know what f of x is. That's going to be given. So the first step is to calculate f of x plus h. Now notice I'm not putting in a specific value. I'm still using this general value of x. And a lot of this work is going to look very similar. The second step is to find f of x plus h minus f of x. And as before, I'm going to call that delta y. What do you think the third step is going to be? Yeah, delta y over h. So simplify delta y over h. And the last step is going to be the limit as h approaches 0 of delta y over h. And that is going to be f prime of x. Overall, this is your derivative function. It's derived from the original function. But if you wanted to look at it over in one kind of big swoop, it looks like this. Limit as h approaches 0 of f of x plus h minus f of x over h. That's what you're calculating. I've just broken it up into a bunch of little steps. But I like those steps. I think it makes it a little bit easier, gives you a little path to follow. That's an F there, in case you're curious. Justin? This is what you're calculating overall. These are the steps in calculating it. So there's 4 steps. This is kind of a look at the big picture. And so what I do is I first calculate this. Then I calculate the numerator. Then I divide the numerator by h and then simplify that. And finally I take the limit. So those 4 steps. We're going to apply that to problem number 34. Now 34 is going to have a little bit more going for it than just what we're going to start out with. But we're going to start out by calculating the derivative in 34 of the function f of x equals 2x squared. So several steps here. The first step is to find f of x plus h. Now I'm not putting in a specific number, I'm just keeping that x. So that's 2 times x plus h quantity squared. Please, I hope at this level no one's going to square this out as x squared plus h squared. All right, that's a bummer. You'll make my job of grading really easy, but you know. 2 times x squared plus what else? 2xh plus, thank you, h squared. And let's distribute that 2. So 2x squared plus 4xh plus 2h squared. Okay. First step down. Second step, I'm going to calculate delta y. F of x plus h minus f of x. F of x plus h is right here. F of x was given. So let's find the difference in those two. Effectively finding the numerator of this quotient. 2x squared plus 4xh plus 2h squared minus 2x squared. Something nice happens here. Yeah. 2x squared disappears. That cancels itself out. So that's nice. That leaves behind 4xh plus 2h squared. That brings us down to the third step. Delta y divided by h, 4xh plus 2h squared divided by h. Factor out that h from the numerator before you do your cancellation. And then you get some nice simplification. The h's cancel each other out, leaving me with 4x plus 2h. Some of you are chomping at the bit because you're like, oh, I know this. I know the shortcut. I'm sorry, you're still going to have to do just one the long way. The last step here is to take the limit as h approaches 0 of 4x plus 2h.
Are you gonna go over the shortcuts?
Am I going to do what?
Go over the shortcuts?
Oh, we'll eventually learn them. Yeah, absolutely. Yeah, but until we get there, until I've covered in class, this is the way we're going to have to calculate derivatives. It's long and tedious, but no, actually much sooner than that. Yeah, but there's a lot of rules to calculating derivatives, so it's going to take us a little while. All right. What's the limit? 4x. So again, this is going back to your number one rule with calculating limits. Plug in the limit. There's nothing wrong with plugging in the limit. It works. So we get 4x, and I'm going to call that f prime of x. That's your derivative function. If I want to know the slope of the tangent line anywhere, all I have to do is plug in that value of x, and I got it. So let's take a look at that function real quick. I got to change it here. So let's ditch these and look at y equals 2x squared. Let's find the slope of the tangent line, say, at x equal 1. So you're at the point 1, 2. But what would you think is the slope of the tangent line? Is that going to be a positive number or a negative number? What's it going to be there? It should be positive. Now, is it going to have a slope close to 0 or a slope bigger than 1? Or what do you think? Yeah, bigger than 1. All right. So wherever it is that I want to find the slope of the tangent line, I can now plug in those values for x. So if I want to find the slope of the tangent line at 1, f prime of 1, 4 times 1 is just going to be 4. What's the slope of the tangent line do you think going to be at the origin? 0. And again, going back to our function, if I want the slope of the tangent line at 0, f prime of 0 is 0. So I can get the slope of the tangent line anywhere, and that's what the derivative function tells you, is the slope of the tangent line. Don't lose sight of that. We're going to learn some tricks on calculating derivatives, and you're going to get good at calculating derivatives. A few of you who've had this are kind of like giving me this bored look like, oh man, I could have calculated. You're going to be able to calculate this in like seconds. Not even like 3 seconds, you're going to be able to calculate this derivative. I know it's a pain to do it this way, but It's what we got right now. So let's finish up the problem though. I'm hoping that you understand that this is the slope of the tangent line at any point of x. What they want from you is to find the equation of the tangent line so that the tangent line is parallel to this function, to this line. 4x plus y plus 3 equals 0. So I want to know where is the tangent line to this function parallel to this? That's going to take a little thought. But let me help you out this way. Let me move everything to the right-hand side except the y value. Now, why would I do that? Dylan, why would I move everything to the right-hand side? What information can I get now from this function? Let me give you a hint. What information can I get from this function? And what's the slope? -4. So basically, I want to know where does my function have a slope that's -4. That way they're parallel, right? Parallel lines have the same slope. So where does -4 equal 4x? Yeah, when x equals -1. So at x equals -1, the slope of the tangent line here is going to be -4, which will be parallel to this. The only thing left I have to do, if you remember what I put down earlier, I need x1 and y1, and I need m. Those are the things I need to find the equation of a line. I already know what m is. M is -4. My point is -1 for x. But what's the y coordinate? How am I going to find the y coordinate? Yeah, plug it into the original equation. I like that. A lot of times people make a little bit of a mistake and they plug this into the derivative. I got to go back to the original equation. -1 squared is +1 times 2 is 2. So -1 and 2. Let's take these and find the equation of the tangent line then. That's going to be y minus 2 equals -4 times x minus -1. If you distribute that, you'll end up with -4x plus 4, and then I'll add 2, so -4x minus, is it plus 2? No, minus 2, right? Let's think. Plus, minus, I'm going -2. I should have shown another step. My bad. Yeah, because that'd be a plus there when you distribute it to -4 and then add 2. Yeah, we're going with that. Let's check it out graphically. Does this work graphically? We'll find out once and for all. So here's my function, y equals 2x squared. Here's the graph of the line that they gave us. So let's kind of zoom in a little bit. I wanted a line that was tangent to my function and parallel to this one. So I think we did it. There we go. So the black line is tangent to the function and it's parallel to the given function. You can and should check these things graphically when you have a minute. You know, on a test, maybe you're not going to have as much time as you might want, but there's your answer. Let me finish up with giving you a little bit of a hint on problem number 35, which is part of your homework. Anything in terms of a wrap-up for problem 34? You give me some feedback. What does f prime represent? What? Sorry, we're running out of time, so hopefully go back. I'll post this online, and Play it slow. All right. I was cooking. But let me kind of recap a little bit. We need to find this limit. That's the derivative function. You start by calculating the difference between f of x plus h and f of x. The function is given, so we need to calculate f of x plus h. We did that. And then we're going to subtract off the f of x. That gives you the numerator part of that function, of that limit. Then you simplify the division by h. We got this. And a little bit of extra work, we took the limit to get f prime. Now I'm hoping this part of it is okay. All right, that's the important part. This extra part is a little bit of a bonus. It's a little bit more challenging. And if you got lost here, it's all right. I'm not as worried about it. Make sure you can do that first part. I will ask you to do something just like this on the exam. The rest of it was a little bit tricky because you had to really understand what the derivative function tells you. It tells you the slope of the tangent line at any point. Just plug in the value of x, you got the slope of the tangent line. We wanted our slope to match this, -4. So where does -4 equal 4x? When x was -1. So at this point, our function is going to have a tangent line with a slope of -4, parallel to this. And the last part was to calculate the equation of the tangent line. So, yeah, my apologies for going a little bit fast on that. Let me give you one last little tidbit from this section. It's your homework, so if you could just hang on. F of x is x cubed. One of the first things you're going to need is f of x plus h. Let me give you the short answer. It's x cubed plus 3x squared h plus 3x h squared plus h cubed. How would you calculate that? Well, the brute force approach would be to calculate x plus h times x plus h times x plus h. That's a real drag. I'd hope you use a little bit of finesse. You might remember Pascal's triangle. You get each succeeding row by adding the things up above. So I'll put a 1 here to start. 1 and 2 gives me a 3. 2 and 1 also gives me a 3, and then add a 1 here at the end. But these can quickly give you the coefficients of stuff like this. All right, that's all I got time here for. You can look up Pascal's triangle if you want some more practice with that or some help. You can also talk to me for homework. Where is it? Try 1 through 17, 25, 33, 34, and 35. So revisit 34 and also take a look at 35. And I'll think about what else we want to discuss from this section for next time. Page 122.